Hi, I'm Josh Atwell, Cloud Architect for SolidFire. Back again with my friend Rawlinson Rivera, and we're going to talk a little bit about how to take the old way of operating your data center and managing your virtual machines and storage and move it to the new model, which is going to be the vSphere Virtual Volume model. Now, Rawlinson, real quick for those not aware, how is that operating model really changing with vSphere Virtual Volume?
Well, the big thing is that we no longer are depending on silos, bronze, silver, gold, to deliver a particular service, a particular data service, a particular capability. Now we have these abilities to dynamically allocate what the demand on a particular application for its particular disk or object, and provided through the system, through a set of API calls, which is guaranteed from our platform as well as from the storage platform perspective.
And doing that is leveraging storage policy-based management, which is a feature that's been in VMware vSphere for 2 releases now, I believe.
Correct.
And what that's doing is allowing administrators and even storage providers the opportunity to assign policies based on the capabilities that are available to the consumer that's deploying virtual machines. So when you're deploying this virtual machine, you would choose a policy for those disks that met your needs. Now, as you mentioned, traditionally it's kind of been a precious metal policy, gold, silver, bronze, things like that. But moving forward, there's this need to have a lot more granularity. Can you talk real quick about some of the use cases where people are looking to get more granularity?
Well, particularly when you have applications that are defined into different disks, different components. There's obviously a workload profile associated with each one of those applications. There might be an operating system disk, there might be a database disk, there might be a log disk. Each one of those disks have a different requirement, whether it's performance, whether it's availability or whatnot. So now, instead of having to individually place these disks when you deploy them as a form of a virtual machine provision operation, you can now, in a simple operation, define what these requirements are in a form of a policy. It's a guarantee policy that comes from a matching of the storage system as well as what we need to consume from the vSphere side. And now, at the same time, we're able to reduce all of the risks that could be potentially exposed by placing things individually like this, to now doing it systematically, one single deployment, all simplified in one single way.
Okay, so that really changes a lot in how administrators are going to manage virtual machines and deploy them. Now, with storage policy-based management, there are multiple ways to attack that. There's kind of the old way and the new way. If you'll walk through those, I'll draw them out so that we can have the visual to go along with it.
So traditionally, the way we service these storage capabilities, in vSphere, we will categorize things into silos. We'll take multiple LUNs. X LUNs could do certain things, but they were statically and physically defined by a storage admin and a vSphere admin. Now what we're looking at doing is, let's define a policy within the vSphere stack, which is then interpreted by storage policy-based management framework, and then we'll tell the actual storage subsystem how to deal with these components that are coming in. How this is enabled is because now with virtual volumes, there's the use of the VASA 2.0 provider, which our API now has a two-way communication between the storage system and also the vSphere framework. By doing that, we're able to now have a communication which eliminates basically the need of someone having to do that manually. That delivers efficiency and it also reduces risks. If we quantify the level of efficiency that we actually have, that sometimes cannot even be done, depending on the size of the environment. But obviously you can see how in the reduction of risk and being able to deliver guarantee performance values, guarantee service levels to an application, this completely simplifies that, as when you look at it in a way that we did in the past, where a lot of people had to be involved, too many things have to be touched, too many clicks, too many things in play, which increases a lot of the risks.
Yep, and so kind of to highlight what you were just talking about, the old mechanism that we're kind of accustomed to is the storage admin would provide up this fixed VMFS volume. It's tied to underlying storage, specific type of RAID group, specific type of disks, and then that would get its own blanket policy. And that policy would generally be associated with specific tags that they would identify as, let's maybe say that these are 15K drives, right? And they are in RAID 5, RAID 10. And so when they choose, they would have to get that and everything would be bundled in that. But you're saying that in the new model, what we're looking at is you're getting individual policies. So each one of these can have its own unique type of policy, and it can be distributed across multiple types.
Yes.
Now, specific to SolidFire, we're able to identify that each one of those volumes has its own performance profile, and that can then translate into a policy. Now, when doing that, that's when you start leveraging the VASA provider. And the VASA provider is software that runs on the SolidFire system, and it serves as a communication gateway between the VMware vSphere environment and the SolidFire system. Talk a little bit about a couple of the capabilities that the VASA provider provides from the VMware perspective.
So basically, what the VASA provider enables a two-way communication. So now it's not only the storage subsystem advertising what it can do, but now we'll be able to tell you what we want to consume from those capabilities that are being exposed through the system. That two-way communication also enables the ability to translate all of that through a set of APIs, which we basically offload a lot of the processing and the operations down from the vSphere side all the way down to the array, which again is a benefit in terms of performance and everything else that you want to gain into your environment.
Right, and so by leveraging that, you can use these dynamic policies. You can deploy your virtual machines. They can be tied to a policy that is associated with the performance or specific characteristics of the underlying storage, and it be dynamic, right? So if this changes...
Sure. So one of the things that this mitigates too is the ability to sort of mitigate the need to move data. So when we're talking about what this delivers also in the model is the fact that these sort of capabilities that come from the SolidFire volumes are sort of wrapped into one storage container, right? So normally, instead of us having to go from one container to another because of the requirements that are not being satisfied, what happens here is that because we're able to detect and identify the performance characteristics, we're able to efficiently place the objects where they need to be once they match those capabilities. Now, what that delivers from an administrative standpoint is that we have one object to manage. So we have one huge data store that could be potentially storing thousands and hundreds of virtual volumes, whatever the case might be in terms of scalability. But now it simplifies that model. We no longer have to deal with the gold, bronze, silver, and whatever have you, because now that sort of goes away and the system will manage that on its own and also eliminate the ability, the requirement to migrate data around in order to satisfy particularly a workload profile.
So what you're talking about there is let's say the requirements for that disk, that virtual volume or just that even VMDK in some situations, if that requirement changes, by leveraging SPBM, you could change that policy that's associated with that disk and have that move, which would be what would typically happen in the old format, like today. And then leveraging things like the project that we've worked on with vRealize Automation, that would be kind of your traditional stand,
Sure.
right? Moving forward, what we're seeing that we're able to do is, as that changes, we simply change the underlying volume. We can change the performance characteristic or the capacity or whatever it is that defines that policy. And since it's now dynamic, we're able to make that change without moving data, without performing storage vMotion, without putting any lift on the infrastructure. And also, since a lot of these are really, really important things, and application owners can be very, very sensitive about things like storage vMotion of a 2 terabyte database, we eliminate all of that by simply changing the policy and still being able to maintain and ensure compliance. Now, if people are currently not quite at vVols and they're looking to take advantage of that, how might they be able to leverage something like tags to be able to create policies to kind of do a very similar thing?
Well, the beauty of the framework is that, SPBM, Storage Policy-Based Management, is a framework. It's not just a particular product. And while it leverages and consumes VASA 1.0 and VASA 2.0 API capabilities, one of the other type of policies that you can create is the tag-based policies. These are statically defined tags that are assigned to a particular LUN, to a particular volume. Now, you can sort of adopt the new and still work with the old in the same sort of fashion, which that's the biggest challenge in an infrastructure when you want to introduce change. How do I operate it? Now you can sort of start adopting that new model, the new dynamic model, and apply it to the old static model, so that you can have one operating model instead of having to manage two different infrastructures that are serving the same purpose, but because they're somewhat different, they have to be managed in two separate different ways.
Right, and so one of the things that I've been working on with Rawlinson and some other folks here at SolidFire is by doing exactly that, being able to take your traditional VMFS data stores and your applications as their disks are distributed across those data stores, and being able to leverage storage policy-based management with tags as you get started, and being able to do exactly that, changing the underlying storage, but then using that as the same framework that you'll be able to use in the future by leveraging the dynamic storage policies, that are presented up through the VASA provider. I have to say that I have a pretty strong feeling that SolidFire customers who are looking to adopt vSphere Virtual Volumes and implement SPBM early on are probably going to be in pretty good shape as they make that transition into that new operating model.
I think so. I think so.
Well, Rawlinson, I appreciate your time. I hope everybody enjoyed this little chat about the new operating model and how to make the old model work today. That's right. Thanks a lot.